All right, team, we are now moving on to I don't know how I'm going to describe it. Organic chemistry has the challenge that in order to be able to do the assessment, you need to actually know all of organic chemistry. It doesn't fall into nice set categories. So with the astronomy topic, it obviously falls into categories like tides and seasons and day-night and things like that. The energy topic falls again into nice categories. We talk about kinetic energy, thermal energy and electrical energy. Organic is not like that. Organic does not have nice categories because everything in organic chemistry intertwines, and I want to start showing you guys how it intertwines. So the next couple of lessons that I'm going to cover with you guys, it's going to be little bite-sized bits, but it's going to fit into a bigger overarching idea. So what I want to focus on for today is on substitution and elimination reactions, substitution and oxidation reactions, which are two of the types of reactions that you'll be thinking about. What I've provided then, and I'm going to hand this guy out, is a summary sheet of all the reactions and how they interact together. So this is what I'm saying. Organic chemistry, there's lots of intertwined information to it, and this is a nice little summary of it. This is actually going to be really useful for you guys because one of the questions you're going to get on the exam is going to be a reaction scheme question. All right. So you're going to get an exam question that is basically like this, but things are going to be blanked out of it. This is not going to be a resource they give you on the exam. You do need to memorize these reactions. I'm giving you guys it early so you can start making notes on it and start making sense of the information I'm giving you. There's also a backside to this, which is all about identification tests, which is another type of question you're going to get on the exam. So we'll look at the reaction schemes and the identification tests at the very end after you guys have learned everything. But I just want to give you guys little bits of the puzzle so you can start thinking about that. So I'll pass this out for you guys. So you have this as a copy. I did try to put it on card, so it is a little bit tougher so you guys can easily find it, hopefully in your notes. And we will start our learning. We have 2 organic here, Zoe. I believe it. All right. Think everyone understands the organic? Well, maybe it's in the room. Ikaw. Here. Wala. Nasa room. We want to watch a movie. Kasi some of the like science, I would like scientists yeah. So now here you got her maybe watching. All right. So let's talk about this monster. Yeah. We're so scared. Let me get my copies too. Okay. Look out for highlighter too if you guys want to do any highlighting. Pero hindi. Mostly mga siya hindi nagaan. Hindi sila mga pero kasi ito na kasi sila dito. Sila sa question. Ayun, so dun sa sa date for nila. Ayun, so dun. Give you guys some highlights and think you want a color code. May ano? Ano yung tawag? Mapakat. Hindi. It's the color code trying to save money. Legal. Hopefully it's okay. Okay ba? Not to mark these markers are. Alright. Ay, parang ito. Need ko lang ganito. Hopefully they're not exploding everywhere because I know these aren't great. I bought them off Amazon or something. They're cheap. Okay, are we ready? Cool. So the first type of reaction I want to talk about is a substitution reaction. Let me find it on the marking schedule first. Okay. So we know that we have things like alcohols. That would be, say, for example, something like this. So this is an example of an alcohol. All right. I'm going to switch to a marker because I want thicker Say, for example, I have this alcohol here. All right. Are we okay so far? Let's say I want to go from an alcohol to a haloalkane. So a haloalkane is when you have some sort of halogen, say for example chlorine. Chlorine just seems to be my favorite one for some reason, like that. Are we okay with that so far? Okay. A substitution reaction is taking one functional group and substituting it for another. So just swapping it out. You might have heard the term in a lot.
S6 at the beginning. We have your lunch ready for you. See you soon.
Escape room. All right. So, you might have heard the word substitute teacher. So your teacher's not there, so you get a different teacher. Substitute, swap them in and out. Here we call them reliever, but substitute is what we call them back in the States. Or let's say you go to a restaurant and you're ordering a steak and it comes with mashed potatoes, and you ask them, "Can I substitute those mashed potatoes for French fries?" That is another substitution. In this case, for organic chemistry, we're doing the exact same thing. We are substituting one molecule for another, or so say one section for another. So for example, this alcohol is getting substituted out for a chlorine. That is substitution. We're swapping something out. So we're swapping out one function group for another. Are we okay so far with that idea? Substitution. There are a couple more substitutions on here. We can also see that there's a substitution here with the amines. Let's say you have something like this. We're substituting, in this case, the chlorine for the amine group. So all of that is just swapping something out. Again, we have another substitution down here, which is the alkane. I'm just drawing an example. It could be any organic molecule like this. In this case, we are swapping the hydrogen out. So those are our substitutions. I'll also highlight those reactions. So in order for us to do a substitution and to swap things out, you need different reagents, and you're going to have to memorize all these reactions, unfortunately. There are some flashcards online that I can get you guys to help you do it, but I think I might hold off till the very, very end. So if I want to go, for example, from an alcohol to a haloalkane, I need SOCl2 or PCl3 or PCl5. So that to that direction is a substitution reaction, and we're going to keep it that color code of yellow to help us learn them. I could also go from a haloalkane back to an alcohol. I would need potassium hydroxide, aqueous. That is important. So what that tells me is that it's in water. So that's another substitution reaction. I also have a substitution reaction going on here, a haloalkane. If I want to go from haloalkane to an amine, I need to have, again, ammonia, but in this case, I need it to be dissolved into alcohol. So that's what that is referring to, and that's another substitution. You will also need to note if you need heat for these reactions, so watch out for that. And then that there just says alcohol. And then I can also go the alkanes to the haloalkanes. In this case, I would need to have the halogen as the molecule and UV and or heat. So I need to have some sort of catalyst. That's also another substitution reaction. Here. So those are all examples of substitution reactions. I'm just trying to see if there's any others that I might have missed, and I don't think so. Are we okay with that so far? Yes or no? Yes? Right. The other thing to keep in mind with these reaction schemes is that we can start learning identification tests. So for example, we are looking to see, is there an observable change in that reaction to help me figure out the unknown organic molecule? So the problem is a lot of these organic molecules are going to be colorless in solution, so they're not going to be able to visually be able to tell the difference. I need to mix it with another chemical to test, and if the test is positive, then I know I do have that function group. You can find some of them on this already on the other side. So one of the identification tests that we talk about is bromine. And if I have bromine, that is an orange color. And if it reacts, it goes colorless because we lose that in the reaction. So orange to colorless. That can help me identify the alkanes. I'm going to flip it over to the other side where the identification tests are so we can actually see what that is. Ready for me to move it? Don't worry, I will scan everything. Okay. So here are my identification tests, and we see here that we have a slow reaction needing UV light. The orange bromine water will slowly decolorize, and this is a way for us to tell if you have an alkane. So that is a substitution reaction like we were talking about. Color change, like I said, is going to go from that orangey color to colorless. It's going to be a slow reaction, and it's important to note that this is slow because this one over here is fast. So the speed tells the difference. But we'll talk about this one later because that's addition. Are we okay with that so far? All right. The other thing I want to point out is one of the things you have also been able to identify now from this information is the amines. So the amines are in this corner over here. And if I want to identify it, I can tell if it's an amine because red litmus will turn blue and universal indicator will turn blue. So that blue color change tells me you have a base. Bases are blue. So that, again, is another identification test. And we see it over here. Amines stink. Yes, they do. Many smell like decomposing dead fish or something like that. And then if we were going to test it with our indicators, and I don't like how that is not, that's a little bit harder to see. So this is red litmus. It's going to color it a bit larger. Red litmus will turn blue. If you have universal indicator litmus, which is green, it will also turn blue. And if you have it in the liquid form, it will be green. It'll, again, turn blue. And that's because amines are a base. It's a weak base, actually. So that's how we figure out when we have an amine. Yeah, sorry, I'm trying to color code it so you guys can see it. I was trying to save money because it's a lot of money to print color, and I figured this is easier to note. Are we okay with that so far, organic chemistry? So the first thing we've talked about is substitution reactions, and we're looking at the fact that we're just taking one component of that organic molecule and swapping it out for something else. And we can integrate that information into both the reaction schemes and the identification tests. So red to blue, green to blue, green to blue. In all cases, they're going to blue. Yeah, I'm just going to color it as a little bit more obvious. All right, are we okay so far with that? Do we end at 10:30? Oh, we do. I'm sorry. I thought it was 10:40. All right. Let me just quickly finish, and then you guys can go. All right, the other one I want to talk about is oxidation reactions. So that's that guy here. Oxidation is a specific type of reaction. In this case, the only thing I want you guys to be mindful of is you have an alcohol, and it's going to a carboxylic acid. So that's our carboxylic acid component. So this is known as oxidation. Let me get that color. Ooh, that's not working very well. So this is oxidation. Other things to note is that carboxylic acids are acids, and so they will turn blue litmus red, or they will turn universal indicator orange or red. You can test for that in many ways. You can test for that with, you can make this reaction occur with potassium permanganate, which will go from a purple to colorless, or you can use dichromate over here, which is going to go from an orangey color to a green color. Also means that this is the identification test for alcohols. Now remember, it only works with the primary alcohols. Only primary. And then if we're looking at our reaction tests, where are you? Primary alcohols, here you go. So primary alcohols, it will turn from orange to green. Or if we're using permanganate, it will turn from purple to colorless. I'm sorry, there's lots of colors going on. So it's how we can tell if we have an alcohol. That starts us off. And then also with an alcohol, you wouldn't expect it to change any color. So if you had red litmus, it would stay red. If you had blue litmus, it would stay blue. If you had universal indicator, it would stay green. And that's because it is not acidic or basic, it's neutral. So it's another good way to test. And then carboxylic acids, remember they are acids. So blue litmus will turn red. Green to red. It's the other one. All right, there you go. That's everything. There are SciPad pages that tie onto those if you want to practice those reactions. Sorry, it was a bit rushed.